In this video, I'm going to explain potentiometer with RGB LED. RGB LED. Generally, potentiometer is a three-terminal device. It is used to generate analog signals that ranges from 0 to 5 volts. That means 0 to VCC. First one, potentiometer. This potentiometer is a analog device. It has three terminals. This one is the wiper terminal. This one is wiper terminal. This one is on either side of the wiper terminal. We have the potentiometer has two terminals. Suppose this one is connected to 0 volts of Ardunio board. This one is connected to 5 volts of Ardunio board. Or this one is connected to 5 volts, or this one is connected to 0 volts. Select that wiper pin is connected to one of the analog pins of the Ardunio board. The wiper pin is connected to one of the analog pins of the Ardunio board. The Ardunio board has 5 or 6 analog pins. Ardunio board has 6 analog pins. Analog pins range from A0 to A5. Select one of these analog pins from the Ardunio board. That analog pin is connected to wiper pin of the potentiometer. Wiper pin of the potentiometer. Next one is RGB LED. RGB LED has 4 terminals. This one is red. This one is cathode. This one is blue. This one is green. The red select 3 digital pins from the UNO Ardunio board. The digital pins select from Ardunio board are 13, 12, and 11. These are the digital pins. These digital pins of the Ardunio board is connected to red, blue, and green pins of that RGB LED. This is the description of the potentiometer and RGB LED. The Ardunio board has an inbuilt analog to digital converter. The values of potentiometer analog values from 0 to 5 volts are converted into digital values that range from 0 to 10023. In this RGB LED control, by using potentiometer, divide this digital values range is from 0 to 511 and 512 to 768, 769 to 10023. These 0 to 511 values are allocated for red LED indication. 512 to 768 for blue LED. 768 to 1023 for green LED. These are the ranges. The total digital value range is divided into 3. From 0 to 511, 512 to 768, and 769 to 1023. These values are used to control the on and off of that LEDs, red, blue, and green LEDs. Now, we have to write the program. Here we use declaration statements, sketches, sketch for RGB LEDs with the potentiometer control. Next, for the wiper pin acts as a potentiometer. Wiper pin is called as a potentiometer pin. That potentiometer has some values. That value is represented as a potentiometer value. Okay, these are the some integer declaration statement. Potentiometer, potentiometer, capital V, VALU is equal to potentiometer value. Value means getting from the wiper pin of the potentiometer. Assign this value to the one of the Arduino board analog pins. Arduino board's analog pins are ranged from A0 to A6. I will take A1. Here A1 is assigned for this potentiometer value. Next, not value here, potentiometer pin. That means wiper pin. Potentiometer P is capital 1. Potentiometer pin. Next one is integer. Initially, in the declaration statement, potentiometer here comma value V capital value is 0. Here consider 3 digital pins from the Arduino board. This one is A1. This one is A1. 3 digital pins. In the declaration statement, mention this one. Red pin. Red pin P is capital 1. Select 13th digital pin of the Arduino board and integer. Blue pin. Blue pin. Select 12th pin. Assign that blue pin to 12th digital pin of the Arduino board. Integer. Green pin. Integer. Green pin. Assign is 11. After a declaration completed, next void setup. Void setup. Preparation block. Here we use one important statement here is serial dot begin 9600. That means the speed of the operation between your UNO board and your system or desktop system. The baud rate is 9600. That is very, very important mention here. S is capital. Serial dot begin 9600. Next, here potentiometer. Here potentiometer pin is the input pin. These are the output pins. These are the output pins. This one is the A1 is the input pin. Mentioned here in preparation block. Pin mode. Potentiometer pin. That pin is the input pin. Here input. Pin mode. Red pin. Red pin. Output. Pin mode. Blue pin. Output. Pin mode. Next one is green pin. Out. This one is preparation block is completed. Next void loop. Next, initial the potentiometer value here. Potentiometer value. V is capital. Value is equal to that value is analog in analog read. Analog read R is capital. Analog read. That analog value is read from wiper pin. Wiper pin is assigned to potentiometer pin. Potentiometer pin. Here, the wiper pin is attached to here. Wiper pin. Here P is capital. Potentiometer pin. This pin is A1. Potentiometer pin is A1. Read analog values from 0 to 5 volts. These analog values are converted into digital values. The Ardunio board has inbuilt digital one, analog to digital converter, 10-bit resolution. 10-bit means 2 power 10. The value is from 0 to 10,023 value. Select one of the analog pin from the Ardunio board, that is A1. Next one, serial print. Serial print LN. Potentiometer value. This is the potentiometer value, that is analog in nature, that means 0 to 5 volts. This is the syntax which is used to read the analog information. That means analog read. That is potentiometer pin, that is wiper pin. That wiper pin is assigned to A1 analog pin of the Ardunio board. Here that statement indicates, the syntax indicates serial.println. Print the digital information. Print the digital information. That means it converts 0 to 5 volts analog information into 0 to 10,023 digital information. These two statements important is like that. Next, coming to this one, already I have mentioned 0 to 511 for a red LED. For a red LED control, 512 to 768 for blue LED control, and 769 to 1023 for green LED control. By using these digital values, how to write the program. This is the consider potentiometer value. 0 to 5 volts are already converted into 0 to 10,023 digital values. Okay, consider this division and how to write the program. If two brackets open, potentiometer. If potentiometer value, the potentiometer value greater than 0 and here continuation, but space is not available right here. Potentiometer value less than or equal to 511. Okay. Considering these values 0 to 1 to 511, greater than 0 means 1 to 511, or greater than or equal to 0, whatever it may be mentioned here. Greater than 0, that means 1 to 511. Instead of here 0, here we use 1 to 511. 1 to 511. Digital write. Digital write. Red pin. Red pin is high. Red pin is high. Next, digital write. Blue pin low, digital write. Green pin low. By considering the range from 1 to 511. Curly bracket is closed. Curly bracket is closed. And we have to mention here some delay 100 milliseconds. That means 0.1 second. Next, coming to again, curly bracket is closed here. One more important point here is again write potentiometer value, analog read potentiometer pin. For red LED, the statements are completed. Next step is for blue LED. Next, potentiometer value. Potentiometer value is equal to analog read potentiometer pin here semicolon if two brackets open potentiometer value greater than 511 and potentiometer value less than or equal to 768. Two brackets here are two brackets are important. Two brackets otherwise indicate some error. Digital write red pin low, digital write blue pin high, digital write green pin low. But delay is delay 100 milliseconds. Task is completed for blue pin. Next, coming to green pin potentiometer value again. Analog read potentiometer pin. If potentiometer value greater than 768 and potentiometer two brackets are open. Potentiometer value less than or equal to 1023. Two brackets close. Digital write red pin low, Here there is no gap here. Digital write. Blue pin low. Digital write. Green pin high. Green pin high. Task is completed. Curly bracket is closed. For white loop, we use another curly bracket, but here some delay. Delay is 100 milliseconds. The program is completed. Now we will see the TINCKERCAD platform. Simulate this program. This one is the RGB LED. RGB LED has already explained 4 terminals. This one is red, cathode, blue, and green. For a red pin, or blue pin, and the green pin, you have to choose 3 digital pins from the Arduino boards. The 3 digital pins are 13, 12, and 11. These red pin and blue pin and green pin are connected to these 3 digital pins of Arduino board through resistors, 220 ohm resistors. Next, cathode. Cathode of the RGB LED is connected to ground. Cathode of the RGB LED is connected to ground. This is the potentiometer. Potentiometer has 3 terminals. Terminal 1, wiper, and terminal 2. Here terminal 1 is connected to ground. Terminal 1 is connected to ground here. Here 5 volts, and here ground is there. Ground is here. Some have to create ground connection on the board, breadboard. Ground connection on the breadboard. Okay. The wiper terminal 1 is connected to ground. Not a wiper. Terminal 1 of the potentiometer is connected to ground. Wiper terminal, that means potentiometer pin, is connected to A1. That means A1, analog pin of the Arduino board. 6 pins are there, already explained. 1, 2, 3, 4, 5, 6. I have selected one pin, that means that is A1. A1 is connected to wiper pin, that means analog pin. Here terminal 2 is connected to 5 volts. Terminal 2 is connected to 5 volts. These are the connections. Coming to code. So this is the code. Already I have explained this code. Potentiometer pin A1. Initially the potentiometer value is 0. A red pin, blue pin, and green pin. This is the initialization. Serial dot begin 9600 means the speed of the operation between system and the Arduino board is 9600. That is baud rate, bits per second. Pin mode. The potentiometer pin is the input pin. The remaining are red pin, blue pin, green pin are the output pins of that RGB LED. Here, the division from 1 to 511, 512 to 768, 769 to 1023. If potentiometer value, this is the potentiometer value that is converted into digital value. 0 to 5 volts are converted into 0 to 10,000, 1023. Divided into 3 portions, 3 regions. First one is 1 to 511. For 1 to 511, these are the statements. For 512 to 768, these are the statements. From 769 to 1023, these are the statements. Here in all the cases, delay is 100 milliseconds. One more important point here is serial dot print ln potentiometer value. That means this statement is used to display the digital values by using serial monitor. See this one. Start simulation. Initially the potentiometer is 0. For 0 to 511, simply 0 to 511, the value changes here. The red LED is on. That indicates glow. up to 511. Here some values are indicated here: 164, 327, 328 to up to 491 here. Slowly increases here up to 511. The red LED is on condition. From 512 to some indication is there in the program. In that program, from 512 to 768, the blue LED is in on condition. See this one here. Blue 768 up to here 768. 768. Slowly increases. Okay, 757. Okay, up to 768, the blue LED is on condition, glow. Next from 769 to 1023, the green LED is on condition. Okay, this is the actual program and related to simulation. With this, with the help of this potentiometer, control the operations of RGB LED, red LED, green LED, combination of three: red, green, and red, blue, and green LEDs. Here, stop simulation. Suppose